I'm 1A. Chapter 4 estimation. Today's topic is interval estimation. Okay. Previous lecture was about point estimation. Let us review a little point estimation. X bar is the best estimate for population mean mu. We started from here, X bar, capital X bar. Here is capital X bar. There are many sample means, realized sample means, okay? And the distribution of X bar is normal with mean mu variance sigma square over n. So sigma over n is standard deviation. In this case, since X bar is a statistic, so we call standard deviation, we call standard error, okay? Standard error of X bar. So standard error means standard deviation. So what I mean is, let's see, for this curve, normal distribution curve, standard error is about here, n over square root of n. When size of n, sample size n, gets larger, okay, then this one becomes smaller. So the spread of X bar, dispersion of X bar, getting smaller, like this, right? That is this one. So if n is very big, 1,000, something like that, then it's going to be very steep here. So small X bar will lie between this small range, right? So it approaches to mu center. Theoretically, extreme case n approaches infinity, then X bar will coincide with mu. Understand that? Okay, let's go to interval estimation. Confidence interval estimation, same way, same thing, same wording. Okay. Interval estimation refers to determining the range within which an unknown value parameter of a population lies. So what range that parameter lies, we may determine that kind of range. To perform interval estimation, concept of confidence level, degree of confidence is necessary. What that mean? For example, it might feel somewhat unsatisfactory to pinpoint the time to reach the summit as 35 minutes based on the reports samples of several people. Instead, it is more persuasive to estimate the time as falling within a range 30 to 40 minutes. Sometimes it's more comfortable instead of just pointing one value 35 minutes. Okay, the problem arises in asserting that the value definitely exists within 30 to 40. Definitely exists within 30 to 40 interval, right? There is no 100% result. Therefore, we need to understand the concept of confidence level, which refers to degree of belief that the unknown value parameter lies within that interval. You understand this confidence level? Okay? For instance, if the estimated time to reach the summit is given as interval 15 minutes to 55 minutes, what is this? This is too big, too broad. The width of this interval too broad to consider it an adequate estimate, right? Anybody can say it's going to take 15 to 55 minutes, right? If the estimate to at time to reach the summit top at 30 minutes to 40 minutes, 30 to 40, sounds good. wouldn't it be a more reasonable interval, right? So the width of this interval is 10 minutes. The width of this interval is 40 minutes, 10 minutes. Actually, in casual conversation, we say it will take about 30 to 40 minutes, right? Not it will take 55, say 45 minutes. We say we take about 10 minute width. Okay, let's go. For example, the interval 15 to 55 could be thought as having a confidence level of 99.9%, almost 100%, right? That is extremely exceptional case, so I don't like to say 100%, okay? While the interval 30 to 40 might be considered to have a confidence level of around 90%. Get it? In other words, a higher confidence level results in a wider confidence interval, while a lower confidence level results in narrower interval, right? So generally, we take confidence level as 95% when estimating confidence intervals. Let's estimate the confidence interval for parameter mu at a confidence level 1 minus alpha 100%. If alpha is 0.05, then 95% confidence level, right? Okay. If you understand this following content, then you can apply that kind of logic to other parameters. For example, sigma square, okay? Say P, we already talk about the sigma square and the P are parameters. For estimation, for the confidence interval for mu, X bar, capital X bar should be used. Why? X bar is best estimator, right? Oh, yeah, here. Therefore, we have to use the distribution of X bar, this one. Again, from what? Central limit theorem. When X bar is standardized, G equal to X bar minus mu, its mean, divided by its standard deviation. Say what? Standard error, n over square root of n. Then G will have normal distribution, mean 0, variance 1, right? And let us confidence level is 1 minus alpha 100%, okay? Then see this graph, 1 minus alpha here, center, okay? Around 0, 0 is G, mean of G, so here is G, then alpha here, alpha over 2, here, alpha over 2, same area. And let's say this value is G, small g, alpha over 2. Then what is this one? Minus G, alpha over 2, because this distribution is symmetric, right? Then we are ready to go further, okay? Today I like to stop my lecture here. Okay, thank you, bye.